Good evening, guys. Welcome to Videos of Account Tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please press subscribe button and notification bell. Now see our updates on this YouTube channel. Thank you and God bless you. This is WAEC 2023 Chemistry Practical under Volumetric Analysis. I have uploaded one of the kind of these question that you can meet in this year volumetric analysis. But I just want to come in this another form in which you can meet this volumetric question in the exam, and this is actually one of the best way of seeing this question, because initially I used 0.05 molar concentration of ACl for for A to titrate to the base given to us. But here we are going to be using 0.10 mol per dm, because that is that is close to the volume of acid that were asked to be diluted in 1000 centimeter cube of water. In the instructional manual, we are given 8.5 centimeter cube to be dissolved in 1000 centimeter, which is approximately Which is approximately 0.1 when you divide it by 1000. So it is actually very close to 0.1 molar than 0.5. So I want to use this one in case we meet this kind of question in exam. What will be our volume of an acid used? Because the higher the concentration, the lower the volume of an acid. Because the initial one is 0.05 molar concentration, and we get 17.45 centimeter cube. And here we are going to be using 0.10 molar, and we are going to be getting 8.75 centimeter cube, half of what we get previously, meaning that the concentration of acid determine the volume of acid to be used. But don't bother yourself with all this of my illustration of volume of an acid used. Just be concerned about the volume of an acid used to be used in your center. What is the volume of an acid used by your teacher in your center? That's what you should be after. You should get to know the volume of an acid used by your teacher, and then come up with a table as you are titrating in your exam that suits the volume of an acid used by your teacher. So please, don't be carried away by this one use volume of an acid and this one use another volume of an acid. Which one are we going to use in the exam? Don't be concerned about that. All you just need to know is the procedure that I use in calculating the value of X, which is the major concentration in this exam. The percentage water of crystallization is what we're looking for. We're looking at the mole ratio of the We're looking at the moles of the water of crystallization. We're looking for the percentage of water of crystallization. These are the major things. And this procedure that we are going to be using is what you should be concerned of, rather than be bothered about the volume of an acid. The volume of an acid is going to be obtained, or is going to be that which your teacher used in preparing your solution for you. So that should be your aim. Just get that volume of an acid in mind, and then when you are titrating, also see that your titration value is close to it. Difference of 0.1 to 0.15. So that's just difference. But I will always advise students to stay within difference of 0.1. So now coming back to this question now. A is 0.10 molar of ACl, and B is a solution containing 1.25 gram of Na2CO3.XH2O in 250 centimeter cube of solution. So this is the information given to us about the two solutions A and B. We are asked to put A into the burette and titrate it against So you have to put A into the burette. The first thing is to clamp your burette on the little stand. This is how the little stand looks like. So then the burette is something like this. If you haven't seen one before, you can check my YouTube channel also to see the video on that titration. So now this is the burette. You are going to clamp your burette, and then you fill it with with acid. This is your This is your funnel. You put funnel and then you fill in with you fill your acid You fill in your acid, so it will be bread. So don't forget your acid will be labeled as what? A. Inside what? Reagent bottle. A. And then your base also inside reagent bottle. As I already said in what? In the other video as well. So we have B. A and B. Now A and B, you fill in A inside what? Inside the burette. You want to put A inside the burette while you pipette what? The base. You pipette the base, then you pipette the base into the conical what? Flat. You use pipette. So this is how pipette look like. For those, I'm just trying to sketch it so you can be sure of what to use in the practical. So this is how pipette look like. Don't mind my diagram. So this is how pipette is. So you pipette it what? Into the what? Conical flask. Add your what? Add your indicator, which is methyl orange. Add your indicator, which is what? Methyl orange, which is 2 drops. Add your indicator after you pipette. Then you bring it back to the what? To the little stand, so as to what? So as to run your acid. Then after you run your acid, then you can now what? Prepare your table. I've explained this in the previous video for those that have watched the video, so you see the what? The titration process there. So we have the bread what? Reading in centimeter cube. We have the raw titer value, the first titer, the what? And the second what? Titer value. Now the first thing you need to do here is to record the volume of A used. Volume of A used is the volume of B used. The volume of B used. And the volume of B used is the same as the volume of the pipette. The volume of the B used is the what? The volume of the pipette. But you can also write it as well. Volume of the pipette. Volume of the pipette used. Some of the pipette used, which is same as what? VD. The volume of the pipette used as VD is equal to 25 centimeter what? Cube. So it's very important because you can either use 20 or 25. So you have to note which of the volume of pipette you are using. Is it 20 or 25? It's very important as far as what? Your center is concerned. Now we have what? We have the initial, final, and what? The initial, the final burette reading. The initial burette reading. And the volume of A used. The volume of A used. The volume of A used in centimeter cube. These are the table will look like. So the volume of the pipette. So after you calculate the what? After you have carried out the process of the what? Of titration. You know, I said this is you remove the funnel after you are filling the what? The acid. Remove the funnel. Filling the acid. So you fill it up to 0, and this is the what? 15 centimeter mark here. The 0 centimeter mark is here. So you fill it what? 0 mark. Then you begin to release. When you release, yes, since we are using 0.1 concentration, is your rough will fall at what? 9.0 centimeter cube, 9.0 centimeter cube, around that what? Area, 8, 9, and so on and so forth. So because this is a rough, it's just to give us what? Where the what? The volume of an acid lies. So now, if you remember, you can see that we use 0.1. When we use 0.05 in the first video, we get 18 for the rough. Now we are getting 9 because we are using twice the molar of what we used the other time. I used 0.05. Now we are using 0.1. So the higher the concentration, the lower. So we have increased the what? 0.1 molar here. We are using that. We have increased the concentration by what? By 2. So that's why the volume decreases by what? 2. So you can see it's not actually different. It's just that the value changes. So the process is still the same thing. So please don't be confused. So that's what I want to clarify by doing this video again. That video is much correct, it's accurate. It's just that the volume of the molar I use is the one that might be convincing. So that's why I'm doing this video, so as to put your mind at rest, and what? Look at the procedure, the process, and mind you, why you can also bring it in that form, because you actually get the same value using the two words, the two information. You actually get the same value. Now, coming back to this now, my rough titer here is 9.0, which is likely to be used in your what? In your center, which is likely to be used in your center. So the volume of an acid what used is what? Is 9.0 for titer, for rough titer. So I'm going to write what? 9.0 minus 00. So minus 00. So we have what? We have our rough titer. Now when I'm carrying out the second titer, so I can, when I'm carrying out the first titer, which is the second titer to my rough, you can fill it back again so as to avoid any form of error. So to 0, I'll fill it back to 0. Now when I carry out the analysis, I get 8.80. Then for the third one, I fill it back again. I have initial to be 0.0 and then 8.70. So you can see the difference here is 0.1. So meaning that this value is consistent. So make sure that your value is also the greater the difference, the highest difference that you can have. Make sure it is between 0.1 to 0.15. But I always advise students stay between 0.1 so that to avoid any form of errors. So if you can use 8.80 in the two titer, you can say to use 8.80 and 8.70. Depends on your choice. So this one is 9.0. You remove this one from this. So it's 8.0. So it's 8.70. So always leave it to two decimal place. So now we are asked to calculate, after doing our result, and calculate the average volume. Now average volume of acid use, average volume of A used is the same thing as what? The volume of A used. So don't be confused. The volume of A used is the same as what? Average volume of A used, which is what? Which is VA equal to the first titer plus the second titer divided by what? 2, which is VA is equal to 8.80 plus 8.70 divided by 2 is equal to 8.75 centimeter cube. This is the answer for the volume of what? A use. So if we are using what? 0.10 molar per dm cube, we are going to be using what? We are going to be using 8.75 centimeter cube for the volume of acid use. So the practical is coming by God's grace. If God give me the grace to do that, you see the practical as well. Now, so 8.75 centimeter cube for 0.1 molar, which is kind of question I'm going to get on what? On Thursday. So now let's now solve the question having carried out what? The analysis. Now, so now the next question is that from your result and information given, from your result and from the information provided, calculate 1. The concentration of P in mole per dm cube. From the information provided and from the table you have obtained, that's your result. Calculate the concentration of B. That's the first question. Concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Now, I told you there are two types of concentration: the molar concentration and the mass concentration. The molar concentration is said as concentration in mole per dm cube. That's molar concentration. While the mass concentration is concentration in gram per dm cube. So when they say molar concentration here, when they say concentration in mole per dm cube, they are talking about molar concentration of B, which is what? Denoted as CB, by CB. Now, in the previous video, I said that there there are three ways of calculating molar concentration, that is concentration in mole per dm cube. Number one is that you can use mole over volume. Number two is that you can use Ca Va over Cb Vb or equal to Na over Nb. And number three is that molar concentration is equal to mass concentration over molar mass. So these are the three formulas that I highlighted in the previous video. But which of these three, which one is suitable for this question? That's the question you need to ask yourself. Now, to know which one is suitable for this question, now you begin to align what the information given to us from the question. Now, from the question, what are the information do we have? Because we are working towards this, we are given what? The concentration of A in mole per dm cube. So we are given molar concentration of A. So Ca is 0.10 mole per what? dm cube. So we are given what? This. And we also obtain Va to be what? 8.75 centimeter what? Cube. Centimeter cube. That's our Va. Now, from there now, we also know what? We also know our Vb. That is volume of pipette, which is equal to volume of base, 25.0 centimeter what? Cube. So also, what else again? We are looking for, don't forget, we are looking for Cb. Another thing that we also have here from the chemical equation is we have the ratio of what? B to A. Don't forget, they can rearrange it anyhow. A is coming second, then Y is coming what? First. So the ratio of what? B to A now, which is NB, is equal to 1 and Na is equal to what? 2. Please note that the question of this one is 2, the question of this one is what? 1. So that's how we get Na and Nb. So I haven't listed this one out, I highlighted this one out. Now it means that what? You can easily use Ca Va over Cb Vb equal to Na over Nb. So that's the best formula. Because if you have to use mole over volume for molar concentration of B, you have to calculate the molar mass, and the molar mass of this is unknown. We are even asked to calculate the molar mass, so we cannot even calculate the mole of B here. So that makes that formula very, very what? Useless. So this CAVA is the best, is the only formula you can use to get your B here for concentration of B here. So that's why we are using now CAVA over CB VB equal to Na over what? NB. So we have what? All your CA is 0.10 times VA, 8.75 over what? CB. What's your CB? CB is what we are looking for, times 25 equal to your Na is 1, is 2. Then your NB is 1. So you cross multiply. So we have CB times 25 times 2 equal to 0.1 times 8.75. You press your calculator, we have 50 CB equals to 0.875. 0.875. Now 0.875 divided by 50. Divided by 50. So 0.875 divided by 50. We have 0.175 centimeter what? Cube. 0.175 centimeter cube. 0.0175. So please note that 0.0175. That's what I get here. So now that's the volume. It's not volume now. It is mole per dm cube. Let me write it very well. So your CB, the concentration of B in mole per dm cube is 0.0175 mole per dm cube. So mole per dm cube. So that's that about that. So now we are asked to calculate the concentration of B in gram per dm cube. Concentration of B in gram per dm cube. So we have got 2 concentration of B in gram per dm. So this is mass conc of B, simply mass conc of B. So please, you have to know that this one is molar conc of what? B. So that you can remember molar conc of B in any given time you are given such question. So mass conc of B, which is the transformation of B in molar in gram per dm, simply means mass. We can easily use mass over volume because we have the mass here and here we have the volume here. So mass conc of B now will be mass over volume, and this volume must be in dm cube. The volume is in dm cube while the mass is in gram. So we have to convert the volume to dm cube. So the volume here would be what? V equal to 250 divided by 1000. It's very essential, very essential. 0.25 dm cube. So that's that. We've converted it, we divide it by 1000. So therefore, concentration of what? Of B in gram per dm will now be 2.5 gram, 1.25 gram, 1.25 gram. That's the mass. Don't forget the mass is 1.25 gram all over 0.25. So 1.25 divided by 0.25. So we have 5.0 gram per dm cube. So that's that about math 1 and math 2. So 0.0175 and 5.0 gram per dm cube. So let's move to the what? To the molar mass of this. So let me clean this side. Okay. So molar mass of molar mass of Na2CO3.XH2O. So now the molar mass itself will be equal to molar mass of this will be equal to mass concentration of B, because this is B, right? All over molar what? Conc of B. So what's your mass conc? 5.0. What's your molar conc? 0.0175. So this one will give what? The molar mass will give what? Molar mass now will now give you of N2CO3.XH2 equal to 5 divided by 0.0175. We have 285.71. The same answer that we have 71 mole gram per mole. Please note that that's the unit of gram per mole for 285.71 gram per mole. So from here now, we can now calculate our value of X. So it can still contain, well, let me actually what? Number 4, value of what? X in Na2CO3.H2O. What's the value of X now? So that's what we are asked to do. So what's the value of X? Now we have gotten the molar mass to equate this molecular mass. This is the molecular formula of the compound B. Equate the molecular formula to the molar mass or relative molecular mass. We have 285.71. So this one will be 2 into bracket. Sodium is given as 23, 2 into bracket 23. Why is it 2 into bracket 23? Because it has 2 here. Plus 12 plus 3 into bracket 16 plus X covers for this is for these 2 atoms, which is hydrogen and oxygen. So X into bracket 2 times 1, which is given as 2 times 1, hydrogen is 1. 2 times 1 will be 2 plus 16. Now everything equal to 285.71. So from here now we have 46 plus 12 plus 48 plus 2 plus 16 is what? 18. 18x equal to 285.71. So we add this one together, we have 106 plus 18x equal to 285.71. So we collect the like time by taking this one together. So we have 18x equal to 285.71 minus 106 minus 106. So by so doing, we have 18x equal to what? 285.71 minus 106 equal to 179.71. So we divide both sides by 18. This one cancelled out. So x is equal to what? Divided by 18. X is equal to 9.98. So that's the value of x. You have to approximate this. You have to, because the ratio of this word, of this, this number of moles here must be an whole number. So must be a whole number rather. So when you approximate this to nearest number, this one becomes 0 and this one becomes 10. So this is 10. Do you get that? This is 10. So in other words now, if I want to write this expression now, I want to ask the expression now. So the formula must become Na2CO3 dot your x is 10 now, your 10 water. So which is what you have been given in the instructional manual. So this is the molecular formula for the compound, which is sodium triazocarbonate 4-decahydrate. So we have gotten the value of what? X in this, which is 10. The last one is percentage water of crystallization. Please note that percentage water of crystallization. So how do you get that? Percentage water of crystallization is simple, which is the last one, 5. Percentage water of crystallization is simply the mass of, or we can even call it the relative molecular mass of water there, all over the world. The relative molecular mass of the compound. We want to run the formula. So 10H2O times 100. So times 100. So to make this one short, so you know this is 10 water. 10 water is here. 10 water over Na2CO3 dot what? 10H2O 10H2O times 100. So this is the formula that you are going to use. So this one is going to be 180. You can see from that. So percentage water of crystallization will have 180. Because it's going to give you what? 18, just like the bracket gives us 18 here. 18 times 10 will give 180. So 106 plus 180 will give you 286 times 100. So everything in what? 180 divided by 286. That will be 0.6293 times 100, which is 62.93%. So that's that about that. So that's that about that. You can see we still have the same value as what we have for the first video that I uploaded concerning this question. So it's still the same thing. Just follow the same procedure in solving, then you get the answer based on the volume of an acid given to you in the what? In your school. I repeat, the volume of an acid given to you in your school is the one that you should use doing the what? Doing your calculation. Don't use the YouTube average volume of acid use. No, use that which your teacher used to teach you in class, because it's going to what? Give the WAEC feedback on the material he has presented for you to do your exam, and they are going to use that to what, to actually mark your script. So we have come to the end of today's class. If this video has helped you, do well to subscribe and share the video with your friends. Thanks for watching once again. God bless you.